2, 1, and we are live. So welcome guys. I will share my screen right away, or not yet. I will wait. So welcome to our workshop. We're having a NLP workshop today, focusing on LSTMs. If you're not sure what that is yet, don't worry. We'll get to it, and hopefully by the end of this workshop, you'll really have a good feel for it and understand NLP a little bit more. Now, NLP, if you're not sure what it means, is natural language processing. And yeah, let's get right into it. David, if you could send the link one more time just for Danny, in case.
Yo, what a king, thank you.
Okay, awesome. Awesome. So, can you see my screen? Yes, we good?
Yes, sir.
Awesome. Yeah, so this is our NLP workshop, and I will move you guys so that I can see you better. There we go. So if you didn't know, NLP, natural language processing. Now, what we're going to be doing today, we're going to do a little bit of kind of predicting the next word in a sentence using LSTMs. Now, I use Google as an example, as you can see, and what is the weather, and then you have the next predictions of what you might think. Our model is a little bit, it's not that advanced because, Google they have millions of words to train on, and then, they have like extra little things. But this is definitely, you can see the applications of NLP. And so, yeah, that's what we're going to be working with. And I did link the article that we used to kind of understand where we're at, and so feel free to go after our meeting and look at that. So if you didn't know, we actually kind of double as a book club. Today we're going to be reading Pride and Prejudice, the entire book in one meeting. No, I'm kidding. I'm kidding. If you were excited, I'm sorry. If you were about to leave, good thing I just stopped you. We're not going to be reading the book, but we are going to be using it because it's open source, because it's on Gutenberg. It's old enough that no copyright. We're not going to get copyright strikes. And there's a lot of good words that we can use, good sentences. And then, yeah, I know. Maybe one day we read it together. But let's talk about some libraries that we want to import. So we're going to be using TensorFlow. TensorFlow. Then we have Keras. Keras is going to be a big part of what we're going to be using today. We're using the pre-processing, the utils, and the optimizers. Atom. Not too complicated. But the Tokenizer might seem a bit different to you if you've never worked with NLP. That is not a worry. We're also using Pickle, NumPy, and OS. Yes, and there will be a few more libraries, but these are their start ones. So we're gonna open Pride and Prejudice. We downloaded this from Nuremberg. The link should be in the link. There should be a dataset link to it, but you can always reach it. And so we're gonna open it on read encoding UTF-8. And then just to see what we're working with, I'm going to show you. So this is the book, and this is the text that we're going to be using. So, you have all the chapters start, and then you start right away. It is a truth, universally acknowledged. And so, yeah, Jane Austen, that is the author. And just to show kind of what we start off with, this is going to be like the file that we're going to use and kind of pre-process a bit before we use in our model. So in our pre-processing, we're also importing string. And this is not used that much, but we still need it. So we're going to open it again because I closed it. That is also something I wanted to note. If you close it, you don't really need to, but it's good practice. Normally it's recommended because you don't want to start stacking up your memory and having it all cluttered. So then we open it. We have our lines. It's empty. For every I in the file, it's going to go through the file, go through all the lines. We have empty data that we're going to be adding to. So as you see, another for loop. There, it's just details, but it's important because we're cleaning up our data to be able to just put it into our model. And as we know, models can be very sensitive. So we want to make sure, for example, we're replacing our data. We're making sure that for every new line, this indicates a new line. If you didn't know, we're replacing with just empty space because we don't want to have any kind of like error or bias to it that we don't want. Now, we're going to do the same with this, which I believe is raw text. It's an indication for raw text. Just make it a empty string. So just get rid of it, and then you have UFEFF. And we are also going to be doing the same. And then our data is a bit more clean. There are better ways to clean it more in depth, and we'll get there at the end of the workshop. Kind of explain some things that you could do extra. But for our sake, we're doing that, and we're also using a translator. So we're getting that from our import, which is translator. Where did I put it? Did I get rid of it? Well, it was here somewhere. I don't know where it went. Maybe we moved it to the other library, so we can.
What happened?
No, in Keras pre-processing, there was translator here, but I don't know where we went. The translator function, MakeTrans and translate. But no worries. It's not a big deal because it's just one import, and it might be that we moved it to the bottom. So we have our translator, and we're going to use MakeTrans. What we're using this for is, this might look a bit complicated, but really what we're doing is map punctuation to space. And all that means is that we're taking the punctuation that we don't really want. We don't want, periods and so on that might throw off our data. It's just not useful for us. And what we're doing is we're saying, okay, well, put one space for every, character in that so that we have equal amounts of space for each punctuation. So that's all we're doing. And then we're, translating it using our variable that we just defined on what it has to do. And that is our new data, empty again, or Z. We're filling it in. If I is not in Z, we append it. And finally, onto our data, we have a space, and then we join it with all the Z's, right? So far, not too bad, right? If you're confused, don't worry. Also, feel free to interrupt at any point. But it's okay if you don't get it right away.
Interruption.
Yeah.
No, nothing. I was just interrupting. Don't mind me. Please keep going.
You're testing it. See if it works. And it does.
I'm just showing you I'm paying attention. Don't worry.
Hey, that's all good. We're fine with that. Yeah. And so then what we're doing is we're just going to splice our data so that we can show without the space mapping. So this is without the translator. Let's see how that ended up. It's going to be in one long line instead of, remember, we had our entire text, big text, lots of space. Nah, we don't want that in our case. So I just took a random little thing. And as you see, there's a lot of, just kind of words. And that's what we want. Just sentences, long thing. So that will be fine. And now let's see with our space mapping. So first off, you can see with the spaces, because it like added a bunch of spaces, it's already starting at the chapters. So that's already telling you it definitely added a few spaces. But then we get to add actual words. As you see, you have all this blank thing instead of the punctuation that we had before. So just a lot of blank space, but we don't have the punctuations, no dots, and that's what we want. So far, we good? take that as a yes, a resounding yes. We also
Actually, could you repeat that one more time?
repeat this part. Is that what you were asking?
No. Like, did you ask a question? Like, I didn't hear a question in there, so that's why I'm like, wait, what?
No, I was just asking if there was any questions.
Oh, no. No.
Yeah. So
Understood.
that's some meta stuff, asking a question about questions. But yeah, so feel free to ask if you think of something. But again, this is just, pre-processing, getting the data ready for our model, which is really what we want to, understand, because it's really cool. So we have our tokenizer. And so I provided some docs because honestly, sometimes it can get a bit confusing, even for me sometimes. Go back to docs and so on. So this is definitely good references. We added that for the models too, just so you know. So we have our tokenizer, and we're getting this straight from our import. Luckily, we don't have to code that because they make it way better for us. So we can get it. There you go. Call it. Then fit our text to it. Fit the text. This is just a initial step that you do for the tokenizer. Whenever you're going to use this specific tokenizer, you're going to use fit on texts with your data, which remember is our long data. And yeah, so we fit on text. And what we're gonna do right away is we're gonna actually use Pickle to save it. So what we're using is pickle.dump. This is gonna be our data. As you see, we have our data fixed to it. We're adding our data into this new Pickle file that we just created. And you can see on the slide, we already have it ready, so we don't need to wait for it.
Quick question, actually.
Yeah.
So, okay, I could be wrong on this, but from what I understand of Pickle, it essentially saves models.
You can definitely use it for that. So and we use it later. Yeah, we do use it later, and David will talk about that. But
actually, I don't use it, but
we do
because I use the Keras version of it.
Oh, true.
But you can explain what Pickle is, though, right?
What do you say?
That would be awesome.
What
explain what Pickle is essentially. That'd be awesome.
Oh, okay. Well, first off, David will reiterate it in the Keras version too. But so Pickle, you're just you're serializing it so that you can. Well, I think I mentioned this even last time. How I remember Pickle is think of the actual pickling of things. You put it in vinegar, you store it in a jar, some other things, and it will last a super long time. So what you're doing with this is you're putting it, almost like in a little jar, and you're saving it for later. So in terms of what you asked, Daniel, about can we use it for models? We can, because we don't want to, you spend 3 hours training something, and then you don't want to keep training it. Yeah, you want to just stay off of where you are. It's like a little saving spot, like a checkpoint in a game, right? You don't want to start off fresh, speed run it.
Absolutely. And I guess after you trained, let's say for millions of Amazon reviews, you're gonna want to keep it at whatever state it's at, just for new data and not necessarily for training.
Exactly. It's just like a little saving spot, if you will. Right, David? I'm not butchering it by saying that, yeah? Good. I hope that answered it, Daniel.
Yes, it did. Thank you.
Okay, good. We'll go into it again a little bit because it's something that's really cool. I was even telling David, I wish I learned that earlier because it's just, I don't know, I find it really cool. But yeah, so back to our thing. So what we're doing, remember, we're using this is what you need to use to be able to use the tokenizer. And then we're running this, and this is very similar, that we need to run it also for the tokenizer. This is like a second step. So what we're doing is we're fitting onto our data into the tokenizer, and then we're turning it into sequences. And so yeah, and when we're doing fit on text, I believe that it makes a dictionary called word index, which is what we're using right here. And we're just using this for the size, which you'll see we'll use in our model, but no spoilers yet. No, you gotta wait for that. And then again, empty sequences. And we're doing for I in range of blah, 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 just so that we can go through it. We're doing the words, sequence data, again, some splicing stuff, not really important to what we're trying to learn. And then we have our, we're appending the words that we just got into our empty sequences. And you'll see what we use it in a bit, which is right now, we're creating, again, same variable, but we're actually turning it into arrays so that we can use it in our model and in everything else. Just, arrays. And like normal convention, we have our capital X for data and lowercase y, empty. Then we append it. That's why we created it into arrays. We append it. We, put it to that variable. We have our array again of X that is appended. And then Y to categorical. So you're taking the data and turning it into, putting it into different categories. And here we see actually our first use of size would be, there, size would be, which is the number of classes, our size. And then to visualize the arrays, this is not really needed. I mean, just know that they're arrays, but I thought it might be nice to just see that it's there, it exists. And there it is. It's cut off, obviously, because that would be a lot to display. But yeah, before I give it to David, is there anything else? Are you guys excited to see the LSTM? Hear from David? He's been waiting. Oh, is that?
Hey, all right, pass it over.
Okay.
All right, thank you, Hermes. Now we're gonna go on to creating the actual model. And before I show you the model, let's talk about what LSTM actually is. So it's a type of recurrent neural network. And the reason recurrent neural networks were made was because scientists wanted to introduce memory into their models, especially for natural language processing. This is important because you need to know what words are coming before and what words should come after. And LSTM is just a variation of an RNN, but it stands for long short-term memory. Basically what it is that it has bigger memory. So it has long-term memory. And I put some references here so you guys can see them. And this is what an LSTM layer looks like. And let me take out the annotations so I can show you what it actually means here. So this line right here, this line, this is the long-term memory line. This is where the memory part comes in. A copy of the layers go into this line and are introduced later on into the model or the layer. And this is actually the input. These are two inputs, and these are outputs. This is actually the long memory. This is an output, and this is also an output. And to show you that it is like that, let me show you a bunch of LSTMs linked together. So for this model, we're going to need a sequential model. This is the same. It's the same old, right? It's a feed-forward neural network again with LSTMs. We're using an embedding layer, an LSTM, and dense layer. For the embedding layer, basically what the embedded layer is that it stores the word representations that the model is going to learn. And I don't know if Hermes mentioned it, but the tokens, the word tokens that we made before in the pre-processing, they're going to be turned into word vectors. And these word vectors are going to be stored here in this embedding layer as word representations. And just a simple example of what that would look like. You can imagine a graph right here. And let's say there's a word right here called, let's say, ruler. And let's say that another word here that's similar, but not quite the same, king. And then another one called queen. Now they're very similar. They're both rulers, but the only difference between them is that this one is male, this is female. And it could also work for deer as well. Let's say deer. I'm pretty sure a female deer is a doe. Oh, actually, I should actually put that at the bottom for continuity. You cleared my. And a male deer is a buck, right?
Yep.
Now you'll see that this is just an example of a word representation where female versions of the words are more at the bottom and male versions of the words are more to the top. And that's what's going on in the embedding layer. Next, we're going to have our LSTM layers. We're going to have a dense layer that's going to have a rectified linear activation, or our output layer, which is going to have a softmax. And the softmax basically going to create a bunch of probabilities on what's the most probable word that should come next. So when we're not pre-processing, we basically created an array with a bunch of the words that are in the text, Pride and Prejudice. And the softmax layer is going to put, okay, we're going to put a probability of like 1.97% is definitely come next with, let's say, and then like a 0.03, well, not 3.25% probability with the word home. These are just words that are in the book, but the softmax layer is going to put a probability next to it and say this is the most probable word that should come next. Excuse me. And here's the model summary. There's 20,376,728 trainable parameters. So you can imagine that this is going to take a while to train, and you'd be right. So usually when you have something like this, it might be a natural language processing model or computer vision model that it's going to take a very long time to train. You want to have checkpoints. And what are checkpoints? This is basically saving the model weights at certain times, so that, let's say, the execution stops for whatever reason, you can start over from the checkpoint and finish the training. And here we have the model checkpoint. You add this in the actual fit when you're putting callbacks. No, actually need this one. And we're gonna have monitor loss. We're gonna have a both 1 for both. Just means, oh, it's just gonna be a little noisy. And mode auto. Then we're gonna have a reduce on. Now we're gonna compile it, and then we're gonna fit it. And this is our training log. As you can see, we did 50 epochs here, with a batch size of 64. And you would usually use more epochs for something like this, because you want to know exactly what comes next after each word. But if you see right here, the time for training of 1 epoch is about a minute. And since there's 50 epochs, that's a training time of 50 minutes for this model. So let's say we were gonna do something like 150 epochs. It would take 150 minutes, which is about like 2 hours and a half. We were not patient enough to do that, so we reduced it down to 50. And then we saved our model using the Keras. Drag over here. And we can load it back using Keras models load model.
Wait, so David, quick question. So why do you use Keras here to save it instead of Pickle? Any reason? Just
the reason is, in Pickle you save as is, but when you use the Keras model save method, your Keras saves it in a way where it's compatible with future versions of Keras. So let's say you were using some new functions in Keras in the future, and you have this model saved in your backlog, or in a directory somewhere, and you want to test it out. You won't be able to test out the new functions on it, because if you save it with Pickle, because it's saved as is. But using the Keras version of save, you actually use that, because it takes into account the future versions of Keras. Right? Awesome. So this is the function we're going to use to actually predict the next word that's coming up. Let's make sure that's coming out. We're going to use the predict class method. It is deprecated, but we're still going to use it. And this is our loop. We're going to input our text. And if the text is STSP, we're going to end the program. Else, we're going to separate the text and predict the next word. All right. So, anyone want to try our model? Let's see. Put it in chat. Put in chat whatever you want.
I better see some sentences. Let's see.
Oh, let's try this one. Let's try this one. Friend Soy Choye. Yeah. Himself. Let's see what our model has to say about I've got a czar. Looks like it doesn't have those words. so it's not gonna say anything actually.
What about?
How about thanks? Damn, thanks was that? Hold on, what's up? What's up with this?
Try it without. Try without.
Is it just deep note not showing it?
Yeah, it could be because it definitely was working before.
Yeah, I'm printing it. What?
Oh, Azar has a sentence for you. I doubt that Pride and Prejudice will output anything, but hey, we can try. But as soon as
let me actually see. Let me STSP. Imagine this doesn't go through. Oh my god, it doesn't go through. It's actually broken.
just try it again.
For some reason, let me run it again. How about now?
It'll work.
Okay, looks like Deep Note just broke on us. They're just gonna have to trust us when we say that it outputs a word after a line.
Maybe refresh it.
Oh man, please.
No, machine broken. Hey, but no slander on Deep Note. It's really good.
Oh no, Deep Note is a goat, but hold on,
Hey,
let me reload.
It's in beta. Let's see if we can get it.
Maybe it's just me.
No, it probably.
Let me make sure.
Let me clear the output.
Well, that's not there. Still doesn't work. What's wrong? Oh. Man, are we really gonna have to restart this?
Hopefully not.
All right, let's move on. We'll see if after restarting it works. But some possible improvements to the model.
And this was we're assuming it works in our possible.
So some possible improvements to the model. We can lowercase all the text that we use for training. If we go up to the pre-processing and you go to the new data, and you'll see how there's some capital letters here around the periods and capital letters here. The reason it'll improve if you lowercase all the letters is that the embedding layer has to learn less word embeddings, because to the model that however with a capital H and however with a lowercase h are not the same word. So it has to do double the work for that word if there is a however that is lowercase. Another improvement that you could do is remove all non-alphabetical characters. When we were testing out this model and we were printing out predictions of words, we sometimes got like double quotation marks, like this one. That's the predicted word that's coming, and you probably don't want that, so you should delete that in your pre-processing. And train the model with multiple tests.
Yo, it works.
Oh, it works?
Yeah. I just said test and it put conquer. So let me get rid of my print statement, but keep going. And I will do that.
Oh, it worked. I don't know what the heck was going on.
It must have been deep now. But
In the model with multiple tests. I think I don't understand what I put there. But moving on, use multiple embedding layers to extract different representations of words. Like I said before, when I was explaining the embedding layer, it's basically holding all what the model thinks the word is related to. And using multiple of these layers can give multiple word representations. And if you have a lot of words, this is probably useful. But we only have one text. We don't really have that many words. But if you're using, like, let's say 5 of the Project Gutenberg books, you probably want multiple embedding layers. So the model has a chance to learn a lot of different word representations for all the words that are coming at it. And we definitely hope that you guys take, or you can download a copy of this workshop and edit it for yourself. Maybe even put it on your resume. But anyway, let's run this line of this cell of code and predict some words. Let's see, what was in here? Java better than Python? That's heresy.
heresy.
Let's just put Python and see what happens. Nothing. How about however little?
Oh, however little.
Okay. Okay, let's make a sentence. Little. However little divided. Okay, divided. However,
Little,
yo, is our LSTM model acting as a mediator between the Javanites and the Pythonians? I cannot believe this.
I think you put Python, so it took a little time to think.
Oh no, never mind.
No, David, you inputted Python, so it returned brilliancy. You know.
Okay, so if you put it in Java, what'll happen?
Java?
Let's test it out.
Probably nothing, to be honest.
Wait.
Because the model doesn't know that word, so it can't predict what's next because it doesn't know it.
Vale.
All right, I mean that's it.
What was that book about again?
Pride and Prejudice. I don't know. Maybe it's like if I remember correctly, it was like a rom-com or something. I don't know.
Okay, so I'm willing to put money that if you put in Pride, Prejudice will come out. Or Pride and.
Oh yeah. Let's see. Okay,
ooh.
Hey.
That's why you want to remove it. How about let's see again.
Consistent.
It's consistent.
At least it's consistent.
How about Prejudice? Oh. I think I spelled it wrong.
But maybe restart
the Prejudice. Prejudice.
Oh, and by the way, don't worry. When I was doing my workshop like last week, it also broke on me pretty hard. So don't worry.
Wait, is it also outputting a quotation mark as a prediction for what's next in Prejudice as well?
It's assuming it's in quotes. It's assuming it's being quoted. Oh, interesting.
Oh yeah, it is. Oh my god. Yeah, it must have been in quotation, but I think we should have taken out the title. I'll put that.
And the chapters. That's definitely something to add. You know, and that's going into optimizing your model. Obviously, you would want to include more than one book if it's possible. You know, the more data, the better. But also because Pride and Prejudice is a pretty old book, so you might want to. Obviously, it's kind of difficult with the copyright, but if you can find one, you might want to take some sort of text that is more contemporary, and create a better model. Because if you're going to say cool, I mean. Cool is an old word. You can use that for temperature, but it won't have the same meaning, and you might want to have several types of meaning. Let's see, cool. Now you gotta test out. Cool. I gotta see what.
All right, I turned it off.
So it's all good. I can run it if you want.
Let me stop sharing. That's all we have for this workshop. But we have a very special announcement about what's going to happen in the next workshop. Right, Hermes?
Oh, yeah. We do, right? Please go ahead, David.
So for next workshop, at first it was supposed to be an open-ended workshop where we talked about anything. But now it's going to be an ask me anything type of thing. So if you have any questions, feel free to ask us in that workshop. If you have a project that you need help on, feel free to ask us about it in the workshop. If you need help starting on your AI path, or you want to know, oh, what do I use for this or what do I use for that, ask us in that workshop. We're really open to anything. It's gonna be really comprehensive, we hope. And who knows, you might advance on your path of becoming an expert Pythoneer AI developer.
Yeah, no, exactly.
Definitely check that out.
You know, and definitely like write down questions if you have any. If you think in the process of this week, we'd love to hear it. I think it's really important to be able to ask something to people, and we're always available on Discord, but maybe by enabling it in a meeting might be a lot better.